Okay, in this question, we've got an electron being fired into a uniform magnetic field. So you're told the magnetic field, you're told that it's an electron, and it's got a velocity in there. So we know that a moving charge is going to be affected by this electric field, or sorry, this magnetic field, which is pointing into the page. We know its initial velocity going in, so we want to know with what force and with what direction is it going to be deflected. Well, the direction we can take care of with our third right-hand rule, but the force, we have to use our formula. QVB sine theta. Sine of theta, it's moving in at right angles, so it's just QVB. Q, which is our charge, it's an electron, so that's 1.6 times 10 to the minus 19. Velocity, you're told it's 3 times 10 to the 5, and the magnetic field you're also told is 0.9. So the force that this thing is deflected with will be 4.3 times 10 to the minus 14 newtons. And now we want to figure out which direction. So let's insert this thing in. So there's my negative. If you follow your right-hand rule, you put your thumb in the direction of conventional current. But this is a negative. So you have to put your thumb this way. Your fingers go in, which means that it ends up going like this. That's its path, which is clockwise. So I'm going to call that clockwise. So there's your force and there's your direction. You'll notice that as this thing is in this magnetic field, it's always getting moved in a circle. So for part B, what's going to be the radius of the electron's motion? This is actually going to undergo circular motion now. So if we would like to know the radius of that circular motion, we just go force of deflection due to the magnetic field is equal to force circular motion. You get QVB sine theta, but sine theta is gone because it's at 90 degrees, equals mv squared over r. And we want to find the radius, so I'm going to do some simplification. This v is going to cancel out one of those v's, and r is going to end up being equal to mv over qb. When I plug this in, I get my radius. It's an electron, so you need to know the mass of an electron, and it's 9.11 times 10 to the minus 31. Velocity that it comes in at, 3 times 10 to the 5. Charge of an electron, 1.6 to the minus 19. And the magnetic field is still 0.9. So your radius ends up being 1.9 times 10 to the minus 6 meters. There you go. Circular motion, magnetic fields, kind of mix them together there.